All right, so this is Algebra 2 Review 1 through 35, Part 2. The year is 2021 school year. The hour is 2:15 and 33 seconds p.m. Okay. Charlie Wiseman is not here. The zombie apocalypse is imminent, although has not hit full swing as of... I'm okay. All right. X squared minus 10x minus 24 equals 0. All we really need to do is factor, but it says solve. Solve means we should find the solutions for x, right? All right, so x squared minus 10x minus 24. So we begin by factoring. What should be the first terms in this question when factoring? X. Thank you. X and x. It is minus minus. So what should my terms be? Minus plus, okay? It doesn't matter if it's minus plus or plus minus. The important thing is that whatever number goes with the minus is bigger than the number that goes with the plus, okay? Numbers that multiply to be 24 but have a difference of 10. 1, 6, and 4? No, they're difference. They have to have a spread of 10. That means they need to be 10 apart. So think like things that are smaller, like 2 and 12. Okay, 2 and 12. Where 12 is negative, 2 is positive. Now we're doing x minus 12 equals 0, and x plus 2 equals 0. So what does x equal? 12 and 12 and negative 2. Those are my solutions. And because it's just math related, there's no real world scenario. We're not talking about distances or boxes or anything like that. We can take both those answers. Okay? Does that work for you guys? That's 19. 4. 22. Oh, you think because it's closer? All right, cool. Identify any excluded values. I have a fraction here, right? Is there anything that's not allowed in a fraction? A denominator that equals 0. So let's start with that, okay? Negative 30 minus 6x, okay, cannot, under any circumstances, be equal to 0, okay? But we have to find out what's going to make it 0. All right, so this is like one of those questions where your mom tells you not to do something and then you immediately go and do it, right? Mom is saying like, hey, whatever you do, do not let your denominator equal 0. And then there's nothing more in the world you want than to make that denominator equal 0. All right, so how do I do that? Add 30. Add 30 to the other side. All right, and now it's like, hey, that's fine, but listen, no matter what, you cannot let negative 6 be equal to 30. I'm just saying, don't do it. Okay, now what? Divide by negative 6. Like, listen, I keep telling you guys to stop doing this stuff, and you keep doing it. What's 30 divided by negative 6? Negative 5. All right, so we should go back and test it. All right, negative 30 minus 6 times 5. Okay. Sorry, not 5, but negative 5. So negative 30, what? Plus 30, right? Which equals 0. And darn it all, guys, I told you not to do that. Okay, so what we're saying is the excluded value is negative 5. Does that make sense? Okay. So now also, it says to simplify. Okay, so I'm going to erase all of this work. It's in the video. You can pause it. You can go back. You can look at it, rewind, all that kind of stuff. Okay, now we want to identify any excluded values. What we didn't do with the denominator and could have done is we could have factored out some stuff from there. What can I factor out of the denominator? No, because both terms don't have an x. Negative 6. Okay, so let's say we factor out a negative 6. Right, that would give me 5 plus x, right? or better yet, x plus 5. Right? Does that work? Does that get me negative 30 minus 6x if I, distribute it back in? Yes. All right, what can I factor out of the numerator? Maybe like a 9. Factor out a 9. What's that leave you with? X plus 5. Okay? Now, what happens here? The x plus 5 cancels out, and I get 9 over negative 6. Does that simplify? 3 over negative 2, or negative 3 halves. Okay, because we don't ever want to leave the negative in the denominator. We can either put it out front, or we can give it to the numerator, but we don't ever leave it in the denominator. So negative 3 halves is our simplified form of it. So we have this, and we have that as our answers. Was I right? Does that match the answer key? Super duper. Okay. Do we understand all of those steps? Cool. All right. Number 4. All right. If we have a matrix times an unknown matrix and it equals a matrix, what is the matrix that is unknown? Okay, so in our graphing calculator, we're going to say that this is matrix A. We're going to say that this is matrix B. Whenever I get all that done, I'm going to select matrix A, and I'm going to hit the little -1 exponent icon next to it. And I'm going to multiply it by matrix B. And that is going to be equal to matrix X. So I am supposing at this point that if we knew that, right, we might have just made some mistakes in our graphing calculator. Okay, now, you're going to, I'm fairly confident, get a question like this on the test. Okay, so just to be clear here, right, it's not going to be enough to write just what I wrote up there. What I want to see is I want to see that you know what these matrices are. So this is what, 1, -2, -2, 2. This is 1, 2, 2, -1, right? Okay, let's finish that. Do we want to see this worked out on a graphing calculator? Awesome. Okay, do you have one? If you don't have one, you need to have it out. You should be working along. Okay, let's clear this guy up. I'm hitting second matrix. I'm going to make matrix A. Oh, not like that though. Second matrix, I'm going to go to edit matrix A. It's a 2 by 2 matrix, so I need my dimensions first. It is 1, -2, -2, 2. Okay, I did that. Hit second mode, hit second matrix so that we can make matrix B. Okay, it is also a 2 by 2. It is a 1, 2, 2, -1. Okay, any questions so far on that, on how to edit those matrices? Okay, because we're about to get to the important part. Are we ready? Okay. So even if you're not ready, you're going to get the video, you're going to get to see it. Okay, the first thing I'm going to do is I'm going to select matrix A. Boom, selected. Now this is the part that you need to remember. Okay, see this key right here, the one that we usually hit second on to get to matrix? It says X to the -1st. I don't hit anything besides that button. I don't hit second, I just hit that button right there. Okay? Now we hit second, that button again to get back into our matrix. We go down to matrix B. All right, so it says A, matrix A to the -1st value times matrix B. Does everybody understand that? Okay, now I'm going to hit enter, okay, and it's going to give me that resulting matrix, which is -3, -1, -2, -3 halves. Okay, -3, -1, -2, -1.5. Okay. this is what you're going to show me. You're going to probably get multiple choice options that look like this. I don't want just that, okay? I want to see that you knew how to plug it in your calculator to get that, okay? All right, that's not much. And it's really tough whenever we have really calculator heavy questions to make sure that I know that you're getting to work and that you're not just, picking an answer or guessing an answer or something like that. So give me as much as you can. Questions there? No? Okay. All right. So those are the questions that you guys had from the review. Are there any other questions that we have not covered that you would like to see done? None? All right, I would say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've covered, there are 12 questions off the review that have been covered. So hopefully that's kind of comprehensive enough for you. Let's see, let's come over. I don't know if this is what I want or not. Might be. Should be. Okay, we'll use this anyway. Let me pull up the test because I'm not sure I even got into. Okay, so question 1 on the test is exactly like question number 4 on the review. Okay, so I'm not even going to go over it. Okay, because there's no need to. We literally just covered that question. Okay, so we're going to erase this and we're going to call it question number 2. Okay, let's see. See how good you guys are with stuff like this. They're going to give you a coordinate plane. 2, 3, 4, 5, 6, 7. Okay. And okay, what is the equation represented in the graph? What is the equation of the line represented in the graph? Okay, I know my handwriting's really bad, which is why you should turn the audio on. Make sure you can hear what I'm saying, so you're not counting on being able to read it. Anybody know what the equation of that red line is? Go ahead. Nope, it is not y equals 4. Okay, in order for it to be what's that? It's x equals 4. It is x equals 4. So vertical lines are always x equals. Now, let me ask another question. What is the equation of the blue line? Y equals -5. Okay? -1, -2, -3, -4, -5. All right, so do we understand that? We should be able to do either one, either vertical or horizontal lines. Okay? Are we good there? Okay. Let's see. Question number 3. Okay. We want to find the zeros. Find the zeros of the quadratic function. Somebody give me a number between 1 and 10. 5? Okay. Give me another number between 1 and 5. Okay. Okay. Find the zeros of the quadratic function 25x squared minus 9. Set it equal to 0. Well, let's see what happens if we do. Okay, so she says set it equal. Here, let me do the rest of it in red so we understand the difference between what the question shows you and what our work is. She said set it equal to 0. Okay, what's next? Add 9 to the other side. Okay, add 9, add 9. So 25 x squared equals 9. Now what? Divide by 25. Okay, divide by 25. Okay, so x squared equals 9/25. Square root it. Okay, square root it. Square root it. Okay, what does x equal? Nope. Okay, when we square root the left-hand side, my answer is both positive and negative. All right? What is the square root of 9? 3. What is the square root of 25? 5. So I should get x equals positive 3/5 and negative 3/5. Now, I'm fairly certain that that will still work, but we're going to draw it up a different way, okay? All right, so this will be in the video, but right now I'm going to erase this work for sake of space, okay? All right, let's see if we get the same thing. All right. I see this as a sum difference. Okay, I have a perfect square x squared minus a perfect square. I see this as 5x minus 3, 5x plus 3. Do we see that? Okay, then I would do 5x minus 3 equals 0. Add 3, add 3. Okay, 5x equals 3. Divide by 5. X equals 3/5. Okay, over here, 5x plus 3 equals 0. Subtract 3, subtract 3. Okay, 5x equals negative 3. Divide by 5, divide by 5. X equals negative 3/5. Okay, the only thing I fear, Mia, is that on yours you have to remember, one, it's not a decimal, and when I'm square rooting an x squared, my solution is both positive and negative. If I am worried about that, right here, notice that my answer comes out both positive and negative. Okay? You have to remember. I don't have to remember with this. Okay? Because it's going to force me to come up with two solutions. Okay? Either way works. All right, questions about that? All right. What time are you out of here? 51? Sweet. We got plenty of time then. All right. Number 4. Okay. I'll just take some numbers. 5. 5x minus 7, y equals what? 8. Okay, give me some other numbers. 15x plus 12y equals 93. Very good. Okay. What this question wants you to do is it wants you to write the matrix equation for the system and solve. Okay. Now, they want something fairly specific. What they are looking for is they are looking for the 2 by 2 matrix times the unknown x and y equal to the known solution matrix. So you would get 5, negative 7, 15, 12, 8, and 93. Now, that's not how, I've taught you guys how to do solving using matrices with a 2 by 3 matrix, right? Right, but what do I have to do in my graphing calculator to solve it? RREF. So I would set this up 5, negative 7, 8, 15, 12, 93, RREF. Now, we made up these numbers, so they might be really wild and crazy answers, right? Okay. The first part, like this part right here is going to be the same on every multiple choice answer. They're all going to be exactly the same in terms of the matrix form. So I'm not concerned that you get that part of it right. What I am concerned that you get right is your X and Y answer. You don't have to use a matrix to get the answer. You could solve using elimination, substitution. You could graph it and find out where they intersect. You could do all kinds of different things. But let's show the RREF method. Okay, I'm guessing that some of you guys would like to see that done again. Okay. So I'm going to pull this up. Again, we're going back to matrices. Clear this. We're going to hit second matrix. We're just going to go ahead and I'm going to edit matrix A again. This is a 2 by 3. So 2, enter, 3, enter. You guys gave me the number, so 5, negative 7, 8, okay, 15, 12, 93. Okay, we're going to hit second mode, second matrix, math. What do you say? Okay, we're going to come all the way down to RREF, not A, not REF, but RREF. And we're going to hit second matrix A, because that's where we put our numbers, enter. Okay, so yeah, our numbers come out really, really weird because we picked kind of obscure stuff, right? So, but our answer for X would be 4.527 with the 27 repeating. Our Y would be 2.09 repeating. Okay, that's how it came out. Okay. So in my answer, this would equal over here. This is the work I'm showing 1001. Whatever this was, whatever this is, effectively my X and Y solutions. That's what I'm recording. Okay. So do we know how to find our answer? Do we know how to show our work? Great. I really love the quiet, no response. Really lets me know that I know nothing about what you know. What's that, Raven? Cool. I mean, I do want to teach you. I don't know how effective I'm at, and you guys don't always, and I'm not saying like you as in just this class, but like it's really hard as a teacher to necessarily know that I've given you anything, okay? So try to help me out where you can. Okay. All right. Let's see. Let's pick, we're going to say at Milan. Okay. Pick 2 subjects that get taught. Math. Okay. There's math teachers and history teachers. Let's see. Give me a single digit number. Okay, so there's 5 math teachers. Okay, how many? Give me another number. 3 history teachers. Okay, there's 5 math teachers. There's 3 history teachers. Everybody has to take one. Okay, each student takes 1 math class, takes 1 history class. We want to know how many possible combinations of teachers there are. Okay, now we're not saying that there's like 5 math teachers throughout the whole school. We're saying there's 5 high school math teachers that you could pick from. There's 3 history teachers in high school that you could pick from. Okay, how many different combinations could you come up with? Okay, does that make sense? All right. So you could look at it like this. Let's make math something like this. 1, 2, 3. Math is this. Okay. All right. Let's see if I got this right. Because we're looking for how many possible combinations of teachers are there. All right. So imagine. Let me erase that. So there's math teacher 1, 2, 3, 4, and 5. History 1, 2, and 3. Okay? Now you only get to take one math, and you only get to take one history, but how many different combinations can you come up with? All right, so it might help to think of it as, okay, 1 with 1, 1, 2, okay, 1, 3, right? The number one math teacher with each of the 3 history teachers, right? Does that make sense? How many times would that take place? How many more times would we have to run this out? 5 more times, right? So, as we look at this, there's 3 options here, okay? And we would do this 5 times, right? So how many different combinations would there be? I think it's 15. Let me double check. I want to check and make sure that that's actually how it works on this question. Okay. Yeah. Okay. So, I mean, it wouldn't hurt to show your work at least somewhat like this, to show how there's 15 different combinations where you could take a different math teacher with each different history teacher, okay? So the short way of looking at it is to say, 5 math teachers times 3 history teachers gives me 15, and it does work out like that. 6. Okay. Let's see. Give me a number between 10 and 20. 13. 13. So there's 13 students. Give me a competition. Like, I don't know, like a sport. Okay. All right. Let's. I don't know. We'll just say like 13 students that play t-ball. Right. In t-ball, everybody gets to bat, right? Okay. So there's 13 students playing t-balls. We want to know how many ways students can go first, second, third, and fourth. How many ways can we go first, second, third, and fourth if we have 13 students? How many students can go first? 13 of them are available to go first. How many of them are available to go second? 12, right? The first kid's already gone first. He can't go first and then go second, right? Does that make sense? Right? How many can go third? 11. And then how many can go fourth? 10. All right. Now what do I do with those numbers? Multiply 13 times 12 times 11 times 10. Hold on. All right, so you said 13 times 12 times 11 times 10, 17,160 ways. Isn't that amazing to think about? I mean, it's completely foreseeable that you could get 13 kids on a t-ball team, right? Isn't it kind of crazy to think that the number of ways in which they could go first through fourth is 17,160? There's 17,160 different possibilities just for batting 4 kids. Okay? All of that proves is why it's nearly impossible that somebody wins the lottery or Publishers Clearinghouse or those types of things. Okay. 7. Okay. They're going to give you a couple different graphs. You need to be able to identify those graphs as being nonlinear, a nonlinear function, a linear function, or not a function. Okay, so nonlinear function, a linear function, or not a function. Okay, so can anybody give me an example of a linear function? On the coordinate plane, what would a linear function look like? Anybody want to draw it? What you think a linear function would look like? No? Well, I'm going to wait till somebody does, or somebody at least tells me. What's a linear function look like? Slope-intercept. Okay, give me an example of a slope-intercept equation that I could draw up here that would represent a linear function. Y equals 1/2 x plus 2. Okay, so it'd be about here, go up 1 over 2, up 1 over 2, something like that. Okay, would you guys agree, granted my line really is terrible, could we agree and say that that's a linear function? Okay, yes, linear function. All right, what about, can anybody draw me an example of a non-linear function? What kind of shape? Give me a shape or a type of a circle. No, a circle's not going to be, it wouldn't, no. I threw you guys off by saying shape, okay? Because a shape isn't going to pass a vertical line test. A U? Good. A U, yes, a U is a nonlinear function. Okay? This is what we would call a parabola or something like that. So non-linear function. Okay? What about something that is not a function at all? How about kind of like a C? Something like that. Non-linear function. Okay? What about what about this? Is that a non-linear function? Why not? It passes the vertical line test? A vertical line passes the vertical line test? No, it does not. Okay? All right, what time do you guys tell me we got out of here? 51. So this is not a function. Okay, either of those are not functions. 8. Okay. We want to write a quadratic function Somebody give me, I just need two numbers. 3 and -8. Okay? Give me a quadratic function that has zeros that are 3 and -8. So we take this, right? So you know how whenever we factor something, we said, let's say it's x minus 7, all in parentheses, and then x plus 9 in parentheses. And we took those individual pieces, we set them equal to 0, and we solved, right? So this is, the 3 and the -8 here is what we get when we've solved. So all we have to do is take the solutions and work our way from the end back to the beginning. Okay? So if I know what the solution is, right, I'm saying that I know that x equals 3, I know that x equals -8. Now undo that. How can I get the 3 back over here? No. Subtract 3 because I want it to be equal to 0 over there. So we're saying x minus 3 equals 0. Add 8 over here. So x plus 8 equals 0. Now what happened before this? It was in parentheses, x minus 3. What was over here? X plus 8. And now how do I get it back to the quadratic? FOIL. X times x is x squared. X times 8 is 8x minus 3x minus 24. Okay, last step. Combine like terms, x squared plus 5x minus 24. Okay? That's the answer. So you start with the solution and you go back to the question. So it's kind of like Jeopardy. Here's the answer. What was the question? Okay? So they said the solution is 3, negative 8. And you would say, what is x squared plus 5x minus 24? Impressive, right? All right. That's probably a good place to stop right there. I'll pick it up with the other class in the morning. Talk to you later.